Okay, so let's think about how we might take the derivative of a multivariable function, something that has an x, a y, a z, maybe an a, a b, or c in it as well. All right, so the trick to doing this, it's given right here in your notes, is that only one of the variables can change at a time and the other variables are going to be held constant. So what do I mean by that? So here's that example that I was telling you about, dealing with the wind chill, what it feels like outside. So I've given you a scenario. It says what happens if the wind temperature, the actual degree temperature outside is 40 and the wind is blowing at 10 miles per hour. So then we have two cases that we can consider. And if we look here, this one says that you leave the temperature alone. You are 40 degrees here, you're 40 degrees here. So here the temperature is constant. So that's what I mean by constant. Exact same number. Whereas the wind speed is changing, right? So you'll notice the difference is right here where the wind speed varies. Okay, so if you go back up here, you'll notice I said only one variable can change. The other variables are held constant. So here's your changing variable. You notice you're going from 10 to 15, but the temperature is not going to change. So then my overall question would be, what's the wind chill? Okay, so then if you look at scenario B, and you look closely at that relative to the original scenario that I gave you, notice I said you start at 40. This one says the temperature changed to 45. So now the temperature varies, whereas look closely, the wind speed is constant, right? So, and that's what I wrote here in your notes, the wind speed is constant. Okay, so only one of your variables can change. You can't do, you can't change all the variables or multiple variables at the same time in this class. Okay, so I have to teach you the most basic form of the partial derivatives, which is only one variable can change. In the real world, multiple variables change all the time at the same time, right? But in this class, we'll only let one of the variables change. All right, so I want to look at the example that I gave you right in the notes to see if we can make some sense of that. So let's go over here. I'm going to start from scratch. And I'll say, f of xy equals 2x plus 3y. So let's see, what if I said, what's the overall change in my function if x is changing, right? What's the change in your function if x is changing? Okay, so this is fine, but it's notation for a single variable if I only have one variable. So for example, if this was 2x squared plus 3x squared, right? But this is a y. So I have to be careful because the notation is going to change. So what I'm trying to find is delta f, okay? And that notation is in your book, delta x, right? So as soon as you write this curvy d, it indicates that you are taking a partial derivative and there's more variables than just the x. Look, there's an x there, there's a y there. All right, if you don't want to put that down, you can simply just say f sub x, like that. Okay, so before I get too excited about that, and I get it, this is really exciting, I'm going to write this down one more time because I'm a little curious about what's going to happen. Equals 2x plus 3y. All right. Now, this one says right here that x is changing, right? So the x is changing, which means that the y, if the x is changing, let me write this down. If x is changing, it means y is constant. So what I'm going to do is I'm going to put in a number for y. Try not to use 0. 0 is deceptive. I don't know. A lot of students tend to like 1 because 1 is an easy number to deal with. So this function here is behaving just the same as f of x 1. Right? So 2 times x plus 3 times 1. Okay? So the point is that the y is stuck at 1. It's not going to go up from 1. It's not going to go down from 1. It's just 1. Right? So the derivative of what I see here, f of xy equals 2x plus 3y, will be the exact same thing as the derivative of what I see here. Okay? So if I write this notation down here, so then df dx, or shorthand f sub x, and yes, this is a subscript, it goes at the bottom. This equals, now I can look at this one and take the derivative, and it should tell me what the derivative of that is. So the derivative of 2x is 2, plus the derivative of 3 times 1, which is 3, is 0. And I'm done. Okay, so hopefully you caught all that. I'll run through that again. We're trying to find the partial derivative paying attention to the x's. The x is your changing variable. But y can't change. Y is stuck at a value. Just like the windshield. One of them was stuck at a value. Wasn't moving up, wasn't moving down, and the other one could move around. Okay, so here the y is stuck at 1. Y is not going to move up from 1. It's not going to move down from 1. But the x can be whatever. So when you take the derivative of this, you get 2, and the derivative of 3 times 1 is 0. And this derivative is the same, derivative of this one is the same as the derivative of that, because these behave exactly the same. All right, let's try another one. Okay, all of this is in your notes, so please feel free to look at that. And I just said, let's try another one, but I actually don't mean that. I want to try the exact same problem, but to instead look at the partial with respect to y. All right, so what if we kept going? What if instead we found change in your overall function relative to a change in y? So this says your y is changing. As I said, when you do deltas in this way with the triangles, it assumes you only have one variable. So we're going to rewrite that as df dy or f sub y. All right, so I'm going to circle this because this says that y is changing, which means x is constant. Right? As soon as you figure out what your changing variable is, the other variables have to be constant. All right, so let me go to my original function up here. Right? I'm going to put the work right in here, put a line here. So I'll rewrite it, f of xy equals 2x plus 3y. According to this, the y is changing. So the y can do whatever, but the x is stuck at a value. So a lot of students like to use 1. It's rather convenient. F of 1 comma y. You could use any number. 0 is deceptive. So 2 times 1 plus 3y. So if I take the derivative of this one, it should be exactly the same as the derivative of that. So then df dy, or shorthand f sub y, equals the derivative of 2 is 0 plus the derivative of 3y is 3. So your answer should simply just be 3. Okay, I'll say that again. The derivative of 2 is 0, derivative of 3y is 3. So when you combine those, your answer should be 3.